بسم الله الرحمن الرحيم والصلاة والسلام على المبعوث رحمة للعالمين. Dear students, this is the second lecture that we meet before in Meet Google, and we agreed to make recording for the lectures. So promising for recording these lectures. This is actually the second lecture. We talked before about the outline and explained more details about the power distribution system engineering. So we'll move to this lecture step by step. This is what explained before, the main course outline. Today we'll start for unit number 1, distribution system planning and automation. We discussed the books and some supplemental materials, and also some web links that can help you understanding this lecture. So first of all, we have electrical power system, as we explained. Also in power system, we have generation, we have transmission, and we have distribution, 3 main stages. So our concern in this course will deal with the distribution. This is the third part for any power system. And when we talk about the distribution, so we mean we'll start from medium voltage for the low voltage consumers. So it is very important part actually, and hopefully to understand each part in this course. So in the past, the distribution system was equal in capital investment. When we are going to make capital investment, so the distribution system equal in generating facilities. If you would like to invest, so the generation may be equal to the distribution equipment. And also both represented more than 80% of the total system investment. The figures, as figures shows. So here, for example, the electrical price or electric plant in service. This in billion of dollars. If we see here, for example, the production. This is for some, for example, 1964. So the production may be equal the distribution, and almost here in this year the distribution equal the generation, and also here the distribution may be equal the investment in generation. This is actually the distribution capital investment may be equal in the production. Here more clear about what we explained. For example, if we are talking about the distribution, if for example 39, so in the production to 42, and for the distribution 39, 42, maybe equal, the production equal in the distribution. Maybe of course the transmission investment is less. The transmission investment is less, so maybe the production equals the distribution. In fact, this plan or this chart may be a little bit different now. So if we deal with the generation, for example in Bahrain, for the generations maybe 1.9, but for this billion US dollar. So for the transmission and the distribution means the investment in 1.1. So it's big different now. The situation is maybe is changed. So here in King Saudi Arabia, for example, maybe the generation investment is 36. If you looked about the distribution with the transmission is 23. So now the generation investment is more high than the distribution. So you can invest in the generation more than distribution. For Oman, for example, 6.8 for the generation, maybe the investment for the transmission distribution 4.2. This is the more recent from 2017 to 2021, and also this amounts or this numbers in billion US dollar. Here also this chart shows the price of utility. The price of utility, for example, for the solar PV. This is figures or chart shows the solar's PV values for example 10 cent US dollar per kilowatt hour. If we look about the concentrated solar plant, so this is the cost may be high. For the gas, it is less than the PV. Maybe here in the oil, like this one, the coal for a nuclear for this one. So this chart shows the price of utility scale electricity generation technology in the GCC area. And here we are talking about different kind of plants, for example, PV, gas, and so on. In electrical power distribution is the portion of the power delivery infrastructure that takes from the high imaged. Yani if we talk about for the large generation like this one, so we will move from bulk transmission from 230 750 kV, so we can step down to something called the sub-transmission. Between the bulk transmission and the distribution system, maybe there are some sub-transmission stage for sub-transmission. Maybe you can find sub-transmission, maybe you can from the transmission or generation directly to the medium voltage. So here, because the voltage is very high, so we can step down to sub-transmission, and from sub-transmissions to something called the primary distribution. This primary ranged from 4, for example, to 35, and to the secondary distribution for the low voltage, for example, 120 or 240. So we have here our study, maybe if we looked about this part, this will deal with primary distribution and the secondary distribution. This is our study in this semester, inshallah. What does it mean, primary distribution? Primary distribution lines, as we mentioned before, primary distribution. Primary distributions is if we looked about this part. So we are talking about the medium voltage that ranges from 600 voltage to 35, or sometimes from 4 to 35. This is according to the country. At a distribution substation, this is the main point. At a distribution substation, here at the distribution substation, takes the incoming transmission level voltage in the primary and step it down here, and step it down to several distribution primary. So here we have plenty of primary feeders which fan out from the substation. So here our study from medium voltage primary distribution lines. There are many of primary feeders, and then there is step down to the secondary distributions. This it means the low voltage. So maybe here it's quite clear to understand our study. So here was the generation, here was the transmission, here is the generation from other sites. So in this part, this we what studied in the power systems in the last semesters. So now we step down to sub-transmission. From the sub-transmissions, we have start our study. So from sub-transmission to distribution. Distribution, it means here we have distribution substation. From sub-transmission, there is distribution and distribution substation. It means the voltage comes from sub-transmissions will step down to many of primary feeders. Here there are many of primary feeders. So this is the distribution feeders. This is the distribution feeders. And from distribution feeders, there are some transformers, so-called distribution transformers. These distribution transformers to step down to the customer service at the low voltage or secondary voltage. So here our concern from the distribution substation, it means we have main transformer, main of distribution feeders or primary feeders. So here we step down the voltage through this distribution transformers and then to the secondary services or the customers. Close to each end user, it means a distribution transformer. When I see distribution, say distribution transformers, it means distribution towards the distribution transformer here. The distribution transformer takes the primary distribution voltage, so this is the primary, and step it down to a low voltage secondary. Here the low voltage secondary voltage from the distribution transformer. Here distribution transformer, the secondary distribution circuit connected to the end user, where the connected is made as the service entrance. So here this is so-called the distribution transformer. This is the primary feeder. Let's go to some information about Oman grid. Here the consumer is connected at high voltage and the low voltage. The high voltage is the medium voltage from 33 or 11 kV. There are some tolerance here, and in the low voltage in the Oman grid for 15 and 240, there are some tolerance. This voltage plus or minus 6. Also, we have some limitation. Of course, the frequency deviation in Oman, of course, it will be different from Egypt, from USA, and so on. It's very important. The frequency range, it is not constant for all the country. For during normal operating condition, the normal system frequency at 50. And the normal will be controlled by Oman Electricity Transmission Company, OETC. So this is the range 49 to 95 Hertz and 52.05. But during exceptional steady state condition, during steady state conditions, by the way, frequency deviation will not exceed 49.5 to 50.1. It is very important. For some disturbance or circumstances prevail under some disturbance conditions, the frequency of course can be reached to 51.5 Hertz or fell to 48 Hertz. So during the steady state, so it is acceptable for this range. Exceptional steady state condition frequency will not exceed this value, unless disturbed circumstances prevail. But under disturbance condition, maybe increases for this value. So cannot increase more than this value or less than this value, not acceptable, and some kinds of control for frequency or the trapping system should be activated if increased or decreased from this value. This is concerning Oman. Actually, for voltage waveform quality, it is very important to also, when you study with distribution, to understand There are some standards, for example, for the voltage regulation and something like that. So the voltage waveform quality, this is a standard actually, or operates and the plant connected to the distribution system, and that part of the distribution system at each connected point should be capable of withstand the following distortion of the voltage waveform. So here are some distortions for the voltage waveform. Of course, we are talking about the harmonic and the phase imbalance. So that is the standard or limitation for a main grid. The maximum total level of harmonic distortion on the distribution system is 33 kV and 11 kV. It's very important from all sources under post-normal planned outage and fault outage condition shall not exceed the total harmonic distortion for 2%. So maybe we'll have some problems or some examples when we calculate the voltage regulation, the harmonics distortion. So it is more than this one, it is not acceptable. So for the many grid, 2%. So during your study for design or planning, the harmonic distortion not increase more than 2%, with no individual harmonic greater than 1.5 unless abnormal conditions prevail. At low voltage, the maximum total level of harmonic distortion from all sources shall not exceed 2.5%. This is good actually. So here we are talking about the medium voltage 33 or 11, we have 2%. For low voltage 2.5. It is very important to keep in your mind this standard. The maximum negative phase sequence component of the voltage, we studied the negative phase sequence in the power system in more details. So the maximum negative phase sequence component of the phase voltage on the distribution system should remain below 1% unless abnormal condition prevail. The maximum value is 2% is permitted for phase imbalance. So he's concerning the voltage waveform quality. Quality, it means we are dealing with harmonic or dealing with the negative sequence component and so on. This is the criteria in Oman. Actually, you have to keep it in your mind. If we are talking about voltage fluctuation, if I asked you, what is the criteria, what is the standard for voltage fluctuations for a mini grid? So voltage fluctuation arising from fluctuating demand connected at a connected point to the distribution system actually shall not exceed 1%. So we have voltage fluctuation, we have many of loads, and during variation of load connected at the point of distribution, so not exceed 1% of the voltage level for step changes that may occur repetitively. Any large voltage other than step changes may be allowed up to a level of 3%, provided that this doesn't constitute a risk to the distribution system or any distribution system user. So we have here criteria for voltage evacuation for one, for step changes, for example, switching for some loads. But there are some other than step changes may be allowed up to a level for 3%. So for voltage fluctuation, for step changes is 1%, other than step changes may be of level 3%. Here we are talking about the primary distribution configuration. Primary distribution configuration. So as we explained before, we consider where is our part here for 138 to 12. So there is a step down here. So here we have many of primary feeders. This is the primary feeders actually. What is the primary feeders? For each primary feeders, maybe a 3-phase 4-wire multi-grounded circuit. Here in these primary feeders, there are many of branches called lateral. For example, in a single phase, maybe I take single phase, maybe 3-phase. Here maybe take 3-phase from this line, or take one line, and this is 3-phase, of course. So maybe single phase and make some distribution transformer, or I can take 3-phase and take a transformer with 3-phase transformers, and so on. Here's something called reclosers. This is very important. Maybe you can explain it later. Here also some branches. So this is the primary, and this is many of branches or laterals from the primary circuit. This table is very important to understand a typical distribution system, to keep in your mind for most common values. Here, for example, most common values for substation characteristics, about if we are talking about the voltage, this is some kinds of country using 12.47 kV. Other countries we can use these values for 4.8, 13, and so on. For most common value, number of station transformers may be 2, but other from 1 to 6. Sub-transmission size may be 21 megavolt ampere, here from 5 to 60. Number of feeders per bus 4, number of feeders per bus 1.1 to 8. Here some values about feeder characteristic. For feeder, what is the feeder? What is the peak current for the distribution circuit Brown? The peak current can reach to 400. Some other common maybe from 100 to 600 ampere. What is the peak load? The peak load can reach to 7 megavolt ampere. The peak load can reach to from 1 to 15 megavolt ampere. This is the power factor. This is the number of consumers, maybe reach to 5,000 in this other common, and so on. This is more details about what is the typical distribution circuit parameters. So this is the most common, this is other common values, and you have to keep in your mind these values. Here we are talking about distribution primary. As we mentioned before, we have primary. The main feeders is the primary. The main feeders is the primary. So this is the primary, this is the primary, and this is the primary. This another is called single main line. This is express. This is a very branched main lines with the primary, and also this is the primary, and many of branches in the branched main line. This is typical, and this more branches. Here we are talking about the express. Actually, main express or express feeders is distribution line drawn for substation at a high priority load, like for example a hospital or service only one consumers. This is what it means, express. So express, it is for hospital, it is something special, for example. So here's some different kinds for the primary configuration. Actually here this two radial, it's very important. This is the primary, and this is two radial circuit, normally open ties. Here normally open ties. So during this ring or two radial, this one and this one, and in between normally open tie. This is to improve reliability using this such system. Of course, here's a normally open time. Sometimes it can be closed and sometimes it is open. This is more common use to radial system. Here, primary loop distribution arrangement. This is something it's typical like before, but here actually primary loop distribution. Here some kinds of normally closed, and here the distribution transformer is the primary. We can play as a game in the radial system as before. This configuration is the primary loop distribution arrangement. If any part of the primary circuit here is faulted, all critical customers can still be fed by reconfiguration the transformer switches. So here we can do normally open, normally closed, so this closes open. So sometimes if there is fault, for example, in any area, for example here, so we can open this one, fault here, we can open this one, and we can close this one, and so on. This primary loop scheme is even more reliable service that's sometimes offered for critical load such as hospital. It is very important to use this configuration in the distribution. We have primary loop system, as explained before, are sometimes used on distribution system for areas needing high reliability, meaning limited long duration for interruptions. For example, it is the hospital or the important places. So when we need for high reliability for distribution system, so we can use this design, primary loop system. Of course, in the open loop design, where the loop is left normally open at some points, primary loop system has almost no benefits for momentary interruptions or voltage sag. Actually, here there are different by interruptions or momentary interruptions or voltage sag. Momentary interruptions, it means a complete loss of voltage for the large short circuit. Voltage sag, it means if the voltage is less than 90%, for example, there is a problem. So here we are talking about in case of open loop design. Open loop design, as mentioned before, where the loop is left normally open at some point. If we leave it open, so the primary loop system have almost no benefits for momentary interruptions. If you have voltage or voltage fault here fault, because we have a complete loss of voltage, it means a fault. So or causing a voltage sag. So we can use these features of fault interruption or voltage sags in case of opening the circuit at primary loop. Here they are really operated in a closed loop. Sometimes the closed loop it is very complicated. Here another example for closed loop distribution. It is very complicated actually, this system. It is very complicated to make it closed like this one. So this example type of closed loop primary system is shown. Faults on any of other cable or on the loop are cleared in less than 6 cycles, which reduces the duration of the voltage sag during the fault, enough to hold many computers. Of course, it's very reliable, but it's very complicated and very complex, specifically in the protection. So this is example of closed loop distribution system. Let's move to the critical customers have two more choices for more reliable service where two primary feeders are available. So here for critical customers, we can make design for the distribution system using two primaries. This is primary and this is the primary, and we can use both through these connections. So here the circuit breakers are still different. Here normal open, here normal closed. Here I have something primary. Here I have system secondary selective. Here primary, it means we have only one transformer. For the secondary selective scheme, it means we have two transformers. So this design is very powerful. So we can use two primary circuit for the consumers. We can use this primary circuit for the consumers, or secondary. We can use one transformer, or can use two transformer, and we can use normal open and normal closed, and this is very reliable for critical customer. This is concerning primary and secondary selective schemes. We can move here to another percentage if we are going to make comparison. This good comparison. For example, if we have total load, if we are operating in 5 kV, so we have only this portion of load. But number of utilities that can use 5 kV is this one. So here, if we are using 15 kV, so this is portion of load, total load. So here the number of utilities that can use it may be more than 80%. For 25 kV, so these portions of loads, this is the number of utilities that can use. So this percent is using each voltage class, sometimes using this class of voltage or this class. This is the number of utility. If you log about here, so the most common is the 15 kV number of loads, number of loads, and here number of utilities is more. Once more here, of course, if we ask it what is the main advantage and disadvantage of using higher voltage, it is possible to using higher voltage. For example, what is the main features for using a high voltage, advantage and disadvantage? If we're using high voltage, for example, sometimes one make design for distribution for 5 kV. So another one can use 15 or 25 or 35. So which one is better for the design of the distribution system? So here the advantage for, if we are talking about voltage drop, of course, if you use high voltage circuit, has less voltage drop for a given power flow. If you are talking about the capacity, using a higher voltage system can carry more power for a given capacity. For the losses, of course, for a given level of power flow, higher voltage system has fewer line losses. For reach with less voltage drop and more capacity, higher voltage circuit can cover a much more wide area. Fewer substation, because of longer reach high voltage distribution systems, we need fewer substation. But there are some disadvantages if you are going to use high voltage. From the reliability, an important disadvantage of high voltage, longer circuit mean more customers interruptions. For crew safety and acceptance, crew don't like to work on higher voltage. For the equipment cost, of course, from transformer to cable to insulation, high voltage is very cost. So this is very important to keep in mind when you are making designs for the distribution system. If you are going to use high voltage, there are some advantage and some disadvantage, and if it is acceptable for you, it is okay. Here actually the distribution, so as we mentioned, when we move from the bulk transmission to sub transmission, we will go to the distribution transformer. What does mean distribution transformer? Actually, this is the beginning of the medium voltage, and after the distribution transformer there are many of primary feeders. Distribution transformers comes in many size and configuration. Small substation may have a nominal rating for 5 megavolt. If I asked you what is the distribution transformer, it's 5 megavolt, and sometimes it's reached to 200 megavolt ampere. Here maybe these figures show the distribution substation. Here there are of course the distribution transformer. The rating voltage may be, as we mentioned before, started from 2.5, for example, to 34.5 kV, and most of them deliver energy to industrial and residential. Distribution feeders transport power for distribution substation to consumers. Here, for example, high voltage transmission start here to step down. This is one. So here's a bus bar. Here's the switch gear. Here's a lightning arrestor. Here there are some shield wires. Shield wires maybe is like this one, and shield lines. The shield lines like this one. This using the cable which catch lightning and deliver it to a ground, to the tower, of course, catch the lightning and ground. This is some shield wires here. So here from the high voltage to transformer to the bus bar, so called the distribution transformer. If we looked here, it is typically the same from high, this one high voltage, and this is the transformer. Here the transformers here, the transformers, and to the bus bar, here the bus bars, and then to the feeders or the primary feeders, the output from the bus bar. There are some kind of protection, as we mentioned, called cables which catch lightning. Here actually these figures, it is very important to use two bank stations. When making, for example, if I asked you more reliable system for the distribution transformer, for the distribution substation, for distribution substations, we can put two transformers in parallel like this one. And this is the primary feeders, and this is normally open type breakers. So two bank stations are very common. These are the standards for many utilities actually. Normal utilities size the transformer so that if either transformer, we are talking about the transformer design, so if either transformer fails, the remaining unit can carry the entire substation's load. So here we have maybe 100 of primary feeders. So if we lost this one, so this one should be have the capability to feed all this feeder, and in such a case we have to close the tie circuit. So utility practices vary on how much safety margin is built into this calculation, and the load growth can eat into the redundancy. So here we have redundancy for using this one. Here actually to select the transformer or distribution substation transformer, this what called LTC, load type changer. And in load type changer, so we have many of ranges for the transformers. Actually, these transformers, they can operate in 21, 28, and 35 according to the loads. For example, if we failed for one of these transformers, so here if I have loads with 28, so the load type changer can change it to 28. So if we don't have any emergency and these two transformers work, so in such a case, so these transformers only who can use the type changer for 21 and so on. Most utilities normally use a split bus. This is in between, this is split bus. A bus tie between the two buses is normally left open in distribution substation. We make that such a design, but with this one it's open. The advantage of split bus, if we're using split bus, so we have lower fault current, we have circulating current, they prevent circulating current, so we have bus regulation. So this is the main feature of using the bus with open, when the bus tie is open. Here, having the bus tie closed, if we used or select some substations prefer to use this bus tie closed. So when we use the bus tie closed, there are some advantage. This is a secondary network. When feeders from each bus supply either spot or grid secondary network, closed bus tie help prevent circulating currents through the secondary network. So here, if we use this bus closed, so in the secondary circuit there is no circulating current will be occurred. For unequal loading, so if you have unequal loading, so the using a closed bus tie prefers to use in such case. So sometimes the tie is used open, sometimes it's used closed. If we use it as open, there are some features and disadvantage. If we use it closed, there are some features and also there are some disadvantage. Here actually this is clear example about actually if you cannot imagine the system, so here it is very easy. Here we are talking about the substation distribution. This is we are talking about the primary, and from the primary we are talking about distribution transformer, and from distribution transformers to the consumers here for using maybe 3-phase 4-wire for the low voltage. It's actually layout of grid for low voltage network. Let's stop at this stage. Now we are talking about substation system. Maybe later we can talking about the substation, and this is actually enough for the first lecture. Goodbye and good luck.